Hi everyone, I'm Faisal. I am a Google developer expert. I'm a CTO at Irene. Irene is Canada's first online funeral home. If you guys want to learn about that, talk to me after. But this talk is about Vertex.ai. It's for you and me. How many of you know that what Vertex.ai is here? How many of you have worked with it? I assume nobody, because no one knows what it is. Great. One person, he might be bored a bit, but aside from everyone, everyone else probably enjoy this. So Vertex.ai is very, very cool. And this pitch deck or slide deck is very tiny. It's just 2 slides. See that? Thank you. Because I'm going to do a lot of demos. And I think that's the best way to learn machine learning and Vertex.ai in general. All the amount of YouTube videos and slides won't do justice. If you want to learn machine learning, you just kind of have to do it, and do it on like silly projects and do it on very simple projects, because the concepts are all the same. So my goal here is to talk about what Vertex.ai is, and we'll do 2 projects together very quickly. I've kind of done it like a cooking show where I've already built it just in case it doesn't work. So if it breaks, I can just show the results. But aside from that, we'll see what happens. So let me give you a story. What's Vertex.ai? Google is really good at ML. And so for the past like 5, 6, 7 years, whatever, they've been just paying their PhDs $1 million and getting them to build all sorts of cool ML stuff. And they were pushing all this stuff to Google Cloud. But they had a problem. And the problem was, one, the stuff that they were building was too complicated for a regular developer like us. And when I say a regular developer, I mean, I don't have a PhD in machine learning or anything. I just like to build stuff. And I go on and I find a problem I want to solve, and I'm like, okay, cool. Maybe machine learning can help with this. And if it does, how do I get started? And so I don't want to read research papers. I can't even read them. I don't know what's going on half the time. So I just want to implement. And that's how I learned Android. That's how I learned Flutter. That's how I learned Node and whatever, Go, Lang, and whatever. It's just, I have a problem. I want to solve it. How do I solve it? And so Google had this problem too, where Google had all these tools on Google Cloud, but they had no idea why people weren't using it. Only the most like 1% of companies were using it because the developers there understood like the math behind it. They were able to actually write TensorFlow and write those models themselves. And so Google said, okay, we need to start unifying this and building something. So in traditional Google sense, they called it something else before. They called it AI platform. And AI platform was getting all these different tools and frameworks that Google's written and putting it under one umbrella. But even that wasn't good enough, because AI platform still required you to have a deep understanding of machine learning, which most developers don't. And so Google then started to think about the problem, and what they did was, just like if you've done Android before or Flutter before, you're not really, when you do Android or Flutter or iOS, you're not drawing the pixels on the screen. You're just putting a button in. So in the same analogy, Google said, why are we going to ask developers to write detailed machine learning code when we can just give them the libraries, and as long as they understand the high-level concepts, they can implement this. And so that's where Vertex.ai comes from. Vertex.ai was announced probably a year ago at Google I/O, and it is this cohesive, unification of all their ML tools so that you can build something, get all your data, label your data, train your data, all without writing any code. And if you want to write some code, then fantastic. You can write some code and integrate it deeply within your application. But for most of this stuff, you actually don't need to code, which is why I'm comfortable doing the live demo. Otherwise, we would have, I had to go to Stack Overflow looking for answers. So that's what Vertex.ai is. What's really neat about this is it's not, you might go, okay, well, it's no code. It's one of those bullshit things that we see on Twitter where every other guy and his mom's making a random no-code solution. But it's not. It's actually a very legit thing. And a company I consulted for probably 4 months ago was a company called Boston Dynamics. I'm sure everyone's heard of them. They have that Spot robot. And even Boston Dynamics use Vertex.ai, right? They asked us to write some specific code because, yes, Vertex.ai has no idea about Spot, but aside from that specific Spot-related code, everything else was on Vertex.ai, right? We have another client that I can't name, but they're a very famous customer, and again, that dev team, they have a bunch of data scientists they were able to come up with like a lot of SQL databases and stuff. And then they asked us, can you use Vertex.ai to deploy this whole thing? Because no one wants to sit there and write a bunch of code when it can all be done via no code, and it can be kept up to date and scaled up easily. So I'm going to show you guys. I'm going to just log into Google Cloud here, and we're going to do this together. Awesome. Whoops. Console. So the first thing you do is go create a Google Cloud account. If you don't have one, it's free, and you can probably get like a $200 a month credit or something like that for a while. And again, Vertex.ai doesn't really cost much to get started, especially if you have like toy data sets. And I can tell you about where to get toy data sets as well. But anyway, so here I'm in a project that not just myself, but a bunch of other people use. That's why I'm paying like $200 for this. But it's called Faisal's ML Playground. You can call your project whatever the hell you want. So when you go to a brand new project, let me just switch over to a completely brand new project that's never used Vertex.ai before. Let's go to this. So this is a brand new project. What you'll do is you'll type Vertex at the top. And you'll go to something called Vertex.ai. And when you click it, it might ask you to enable a couple of APIs. And that's because Google's going to say, hey, this is something that you've never used. Do you want to enable access to your account, all that stuff? So there's like stuff here, view tutorials, enable recommend API, and a bunch of stuff. One of the nice things that Google does and Google Cloud does is when you go to a new page, it has tutorials right there. You don't have to go online and try to find something. So you can see on the right-hand side, because this project's never used Vertex, there's a tutorial section there. You can learn what Vertex.ai is. You can learn best practices, migrating, blah, blah, blah. I'm just going to click X. But if I ever want to come back to it, I can click Learn, and I'll see it again. So this is the first time you're on Vertex.ai. This is what you'll see. There's a bunch of stuff on the side, so I'm going to go in one by one. We won't have time to go over all of them in depth. We'll only go over 3 or 4 of them. But this is what I meant by unification. So by default, dashboard, whatever, that's useless. Oh yeah, see, Vertex.ai is not enabled, so yes, please enable it. Okay, so you got dashboard on this entire thing, or enable. Okay, great. Then there's a thing called datasets. Datasets are essentially your photos. So we're going to build a cat and dog detector. So we're going to have a bunch of pictures of cats and a bunch of pictures of dogs, and we're going to see, can the AI differentiate between them. That might seem like a very dumb thing to do, but imagine you're building something. We had a customer that wanted to build something that can detect if, on an assembly line, if a piece of fish is good or not, right? It's been cut up and stuff, but a fillet is good or not. They're using Vertex.ai, right? They're not using anything complicated. They just have a bunch of photos of fishes that are good, and fishes that are bad. I guess they have like, disease or worms or color discoloration. Their PhDs and stuff have figured out that, whenever a picture of a fish kind of has brown spots, that means the fish is going bad. So they've gone ahead and labeled it, right? So this is very important. In the cats and dogs example, I've gone ahead and labeled, these are a bunch of cats, these are a bunch of dogs. But you can do the same with anything you want. You can also have multiple. You don't have to have a binary, which is 0 or 1, cat or dog. You can have cat, dog, elephant, cheetah, whatever. But the more classes you have, then the more images you need. You can't just have like one. The AI is pretty stupid. It's not like a human that, a baby can be like, that's an elephant. Then you have labeling tasks. We're going to ignore feature store. That's more advanced. You have labeling tasks. And labeling tasks are basically, imagine you and your friends go out and collect a bunch of data, right? You guys have 10, 50,000 photos now. You don't want to sit there and manually label 10 to 50,000 images. So you can use labeling tasks, and you can do one of two things. You can pay a bit of money and ask Google to label it for you. So what Google will do is Google will create, you have to upload a PDF, you have to explain to them what you want. So in terms of cats or dogs, you have to write, if it's a cat, please write cat. If it's a dog, please write dog. What Google will do is take all those images and distribute it to their workers. And you pay X amount of cents per label, and their workers will go ahead label it for you, and you'll get a task back saying, look, labeling's done. So this is a great way at your company, if you have a lot of data, to do this. A company that we work for did this specifically with gauges. No, what was it? It was something to do with a factory, and we had to they gave us a bunch of images in a factory, and we had to send a labeling task and explain to the workers, if this is like a gauge of like, with a red color, then you should label this as X, or if it's a blue color, label it as Y. So that's the best part about labeling tasks. Then you have, I'm going to skip over workbench, pipelines, ignore that. Then you have training. And training is, once you've uploaded your images, you can tell Vertex, okay, train this. Now, here's what's amazing about this. Google knows, because there's so much experience behind Google machine learning, they know what best model to use for your thing. So all you gotta tell Google is, please figure out a way to differentiate between a cat or a dog. Google will take that data and run something called AutoML. AutoML is basically, internally, Google is going to deploy your data or train your data on a bunch of different types of models. And it's going to see what model performs the best. So soon there's a model called A, B, and C. Google's going to deploy it on all three, train your data, and if model B performs best, it's going to say, fantastic, model B, your data is now trained, it is 99% accurate, here you go, right? So you didn't have to know the internal implementation detail, you just have to know that I gave it a bunch of data, and now my model is 99% accurate. That's all you really need to know. And so we'll go into that. Experiments are cool because that is if you don't want any insights on the model, but you can go in and start to fine tune a model, which is play around with some parameters and say, you know what, I actually want Google to focus on models of big images or something. And like, these things don't exist, I'm just giving analogies. And then you can go in and you can create experiments. What's nice about this is you're not running anything locally in your computer. All this is running on Google Cloud. So you can run 4 or 5 experiments and seeing how your model performs on multiple types of, how your data performs on multiple types of models. And then when you get a result back, you can say, all right, this sounds good. So an example of experiments also is when COVID hit, my brother was working at a company called Ecobee. And Ecobee is a home thermostat company. And so when COVID hit, everyone just worked from home. Ecobee was not designed for everyone to work from home because it assumed at like 8, 9 a.m., it had trained on all this data that 8, 9 a.m., people go to work, the thermostat would go down, and then at like 4 or 5 p.m., people came back, make the house hotter again. All that data started to freak out. So I remember my brother telling me that they ran a bunch of experiments with different models now that they just wanted to try based on all this new data that was coming, right? Because people's behaviors pattern changed. So you can try all this. And then lastly, you've done all this, but you have a model. And if you're an Android developer, iOS, doesn't matter, web developer, you actually want users to interact with your model, right? You actually want to build an application. So there's a thing called endpoints. And we'll talk about, when we do our demo, we'll go through all this. But endpoints are basically, you get a REST API. And a REST API, you can pass in your cat or dog image, and it will tell you this is a cat or this is a dog. So build your Android app or Flutter however you want, use a REST API, take a picture of something, and then that will be sent to Google, your model will run and give a result back, and there you go, your application's intelligent already. And if you really think about it, you didn't have to sit there and read a paper or write a lot of Python, think about TensorFlow, all this stuff. All that stuff's overkill for most people. When you say now you want to figure out, like count the amount of hairs on a cat or something, right? Then maybe there's no such model, and that's when you gotta learn TensorFlow. So, but for most tasks out there, things exist. And we'll also talk about this website called Hugging Face. Has anyone heard of it? So Hugging Face is a very interesting story as a startup, but Hugging Face is a great website where they might actually have a model to count the amount of hair on a cat. Probably not, but like more specific things, you can go and do it there. But first, let's talk about Vertex. So I'm going to go to a project that I have. Yes?
Question about delivering the task.
Yes.
Is
Yes, yes, of course. So the first option is send it to Google. The second option is when you have a bunch of friends or like a beta test group or whatever, you can actually just invite all of them and get them to label it. So a lot of companies, when they have super sensitive data, like health data, they'll just farm it out to their doctors to do it, and the doctors will use their Gmail account, come on, it's all secure, and then they'll just label each piece of data, and then you're good to go. All right. Yes.
So can the experiments be done simultaneously, or it's a one by one?
Simultaneously.
Okay.
Yeah.
Is there any limit for that?
I think the limit is there's probably a quota, and then you just have to ask Google to increase it. Really, a lot of stuff on Google Cloud is just the limit is your bank balance, like how much you're willing to spend on this. Okay, so we're gonna go to data sets here. And I have two data sets here, but I'm gonna just show you how it works. So I'm gonna click create. And when I click create, here's where it gets exciting. I've just been talking about cats and dogs, but this is very exciting. You can train 4 types of data. You can train image data. So you can say, classify this single label, which is either a cat or a dog. You can go classify this multi-label. So I can say, this is a cat, this is also a tabby cat, this is also a cute cat, right? And then you can go, this is a dog, this is like a German Shepherd, this is a herding dog. And so you can have multi-label classification. You can also do object detection. We had a company come to us once that had a bunch of construction site data, and they wanted us to detect where the people were on the construction sites, right? So we used image object detection to figure that out. We draw bounding boxes around them, all that stuff. And so there's a way to do that. And then there's image segmentation. So you might have seen Mac OS has this feature now where you can like kind of trace a person out. So there's this really popular tool called Extractor or something online where you can like upload an image of you and then it gets rid of the background and then you can replace the background. They're basically using this model, right? You can build your own using this. Maybe they've done it in Python, but you can build the exact same thing and have a REST API that takes an image, extracts everything around it, and just pulls the person out, right? So in our case, we're going to do cats and dogs. But say you don't want to work with images, right? You want to work with tabular data. What can you do with tabular data? And we have this as an example too. We're going to do credit card fraud detection. But with tabular data, I can do regression or classification. So regression and classification. Regression is basically a word to say like the prices of houses are rising or something, right? And then classification is this either a fraud or not? So we're going to talk about some fraud data. And then forecasting is predict the likelihood of certain events. So this is like, your Shopify store is running out of stock. Can you forecast based on different factors that you've given it that you're going to run out of like shoes before Black Friday? So you can build a model that can do that for customers. Then you have text data where, again, text classification, if someone writes on Twitter, I hate Elon Musk, is this like a good thing or a bad thing, right? You can go ahead and label that. Text entity extraction is really cool. We built this. This is a very hard problem. So a company I worked for like 4 or 5 years ago, actually 6 years ago, we were building like a AI assistant, a chatbot assistant. So you can say, book a meeting with Faisal next week. And so if you just think about that as a human, you know exactly what I meant. But as a program, you cannot just write a regex to pull out next week and Faisal, because maybe I write book a meeting with Bob 3 weeks from now, but don't book it on Monday. Like, how do you know what the hell that is, right? And so entity extraction is pulling out certain key phrases, key words from a sentence that can be useful to you. So in this case, if you want to extract full names, right? So say you have a list of like pages and pages of law documents, and you want to extract all the people's names from it, or you want to extract the date or the amount of value. So you can use entity extraction. Sentiment analysis is simple. Is it a good sentiment or a bad sentiment? If you want to do review analysis, if you have comments on your website and you want to know, someone saying, I love this shit, right? that to us, we think as an English speaker, this person really likes it. But if you just do a sentiment analysis, you might go, well, because he used the word shit, this is actually bad, a bad review. So you can come up with a better sentiment analysis rather than just like a regex that does if bad words, then X. Or lastly, you can do video. So you can figure out, and we did this, there was a company that came to us 2 years ago at the start of the pandemic, and they had a bunch of Connect devices, and they wanted to find out if, actually funny and very interesting, they wanted to find out if old people are falling in their retirement home, right? So their idea was, we're going to take these Connect cameras and we're going to put it in all these retirement homes. The company ran out of money, I don't know what happened to them, but we're going to put these cameras in retirement homes, and we want to know if the person gets up and they fall down at night, can the camera detect it, right? But falling down, if you really think about it, is a hard problem. I could just be tying my shoe, or I could be like picking up something quickly. I don't want that to be triggered at 3 a.m. as a person fell down. So the training data was very interesting, because a lot of times me and my brother had to fall down just to like have some data, aside from them giving us a bunch of training data that they already had, because we wanted to make sure, is this working? So you can use video activity recognition to say, these are all the ways people fall down. These are all the ways people just are sitting and picking up a pencil, right? Tell me, when I give you a new video, is this person falling down or not? Classification is whatever, right? Is this like a basketball game? Is this a soccer game? You can build same type of stuff there. And object detection, like it has there, this is kind of cool for, I guess, basketball, but like if you really think about it, maybe you're watching F1 and you want to track, Lewis Hamilton, somehow always losing this year, but you want to track Lewis Hamilton racing, then you can, if you have this footage all the time, then you can always draw Lewis Hamilton there, and it will automatically learn that that car is Lewis Hamilton's car. I'm going to always track it. So this is really good if you're building like, like massive video editing jobs and stuff like that. It's kind of cool to do all this stuff. I've never worked with video object tracking, so I don't fully know all the good use cases. So with that, let's create a cat-dog data set. We have time. So cat-dog data set. I give it a name, simple. I'm going to click create. There's some advanced options, and these advanced options are useful for only one thing, depending on how paranoid your company is. For most customers, Google Managed Encryption Key is good, right? Even like the health customers I've worked for, they're fine with it. Unless your company is like, unless you're like working for NSA, right, then you probably aren't even using Google Cloud. But if you are, you can supply a customer managed encryption key, which means that not even Google can read your data, right? It's encrypted in such a way that only you as a private key holder can encrypt your data, which is really cool because you can still do training on that, right? You still have to supply this key to the public key to different parts of the data, but it will still be able to do encryption. Yes?
That's only at rest, not in transit.
Pardon?
That's only at rest, not in transit for encryption.
For encryption. Yes, it's at rest. So if it's once the data is trained and stuff, it's sitting there. You don't want Google looking at any of your data. It's going to be there, right? So I'm going to skip. I'm going to just do Google Managed Encryption Key. I'm going to hit create. And so it's going to go ahead and it's going to create the data set. So now I have a chance to either upload images from my computer or upload import files or select import files from cloud storage. Import files are basically, you have to go ahead and write a script. I think it's like a JSON format where you have to say, here's an image, cat1.png, and the label for this image is a cat. So these two are if you've already gone ahead and labeled your files already. If you haven't, or if you just have a lot of files, you can use upload import files and just don't give it a label, or you can upload images from your computer. 500 at a time. So yeah, if you have like 20,000 images, that's not what you want to do. In this case, I only have 200 images of cats. So I'm just going to go ahead and click select file. And I'll find dogs versus cats here, train. And all these little cute guys are right here. Show as icons, right? So you can see cats. Who's a cat person here? Fantastic dog person. Wow, more dog people. I will be careful. I will hold my tongue. I'm a cat person. So lots of cats here. Look at her. So I can upload all this, right? I'm not gonna upload. I'm not gonna kill the internet here, but assume I did. And so I end up with something that looks like the following. You know, here's a cat, here's a dog. I've gone ahead and labeled it. But imagine I had this labeled wrong. Imagine this was actually a dog. I can click on it and I can say, you know what, this is actually a dog, right? And where did this cat and dog come from? It's a label that I can create. A computer is not smart. It's garbage in and garbage out. I could call this dog label like Faisal, right? And like the computer will be like, when you upload a picture of a dog, it'll be like, that looks like Faisal, right? It doesn't know what Faisal is. It just knows that here's a string of characters, of bytes, and I'm associating these bytes with this image. That's it, right? So it's very important to kind of understand that as you're doing this, where it doesn't actually know it's a dog. It just knows based on these patterns that it's this label. You can call this label whatever you want. So it's important to label things correctly. So if I wanted to add a new label, I can say cat dog, which was a really fun show. Here's a cat dog, and I can click on this image and I can say, you know what, this is actually a cat dog, right? And I can go ahead and do that. I'm going to ignore that for now. Then I can do the analysis. I have to delete that label because it's now saying, hey, you have no images for cat dog, so I won't be able to train on that. But you can see I have 187 pictures of cats and 100 images of dogs. That's just because my internet was slow when I was uploading this. I'm like, whatever, it's good enough. But the more images you have, the better. I think there's a minimum of like 100 images or something, or 50, where anything below that, the AI won't probably know. It's not a small child. It has no idea what you're doing. And so what I can do now is, now that everything is there, let me delete this cat dog. Remove label. Okay. Is it gone? Okay, so train new model is available to me because I have enough images. So I'm going to hit train new model. And here's where it starts to get very cool. I can either just use AutoML. So this is the no code part, right? I don't want to write Python code. I don't want to write TensorFlow code. So I just hit AutoML, and it's going to go ahead and do everything for me. You can see it's going to train high-quality models with minimal effort and machine learning expertise. Just specify how long you want to train. So the question of how much this costs, you can say, you know what, my company has like a $10,000 budget, so I'm going to let it train for like 80 hours. And you can also say stop if it's already trained and it's not getting better. It's because every time it trains, it measures how good the model is. And if over the course of a long period it's going, you know what, this model is not actually getting any better, it's not going to waste your money unless you want it to. It's not going to waste your money, and it's not going to be like, okay, I'm just training the same shit over and over again. It will stop. So AutoML or custom training. Custom training is if you have written your own TensorFlow, scikit-learn, Keras, all sorts of different stuff in Python, if you want to run it, you don't want to run it locally, you don't want to set up like a VM to do all the GPU training, all that stuff, you can just upload your code and it will use that code, pass in the data, do all that stuff. To date, none of the customers I've worked for have actually done this. I'm waiting for someone to do this because most businesses, what I've realized working in machine learning for like 4 years now, most businesses, unless you're like a Google or a Microsoft that are on the forefront of research, right? Most businesses actually have a problem to solve. They don't want to do research and just have R&D going on and on, right? They just, like even Boston Dynamics. Boston Dynamics has an R&D division and they do a lot of stuff. But they came to us and they said, can you get Spot to do X, Y, Z at a factory, right? That's it. This wasn't research. This was because there was a business problem that they had and they said, please figure it out for us. That was it. So when you see all these new advancements in AI and machine learning, it's really being done by a small group of companies because they have the money to do the advanced research. For most businesses, they're not boasting that they're doing machine learning. They're doing a lot of stuff behind the scenes. Because they have a business use case, they solve it, it's done, and they're making a lot of money off it. So I'm going to do AutoML, and here's what's really cool. Where do I want my model to run? Do I want it to run in the cloud via REST API? Or if I have a Raspberry Pi, if I have something cool, do I want it to run on the edge? I can even have it run on my mobile phone using TF Lite, right? So do I want like this privacy secure thing where someone can detect if it's a cat or a dog completely offline, right? I can do that, edge, or I can do cloud. Now, when you do something on the edge, your phones, have a limitation. They also don't have a lot of storage space or CPU power, all that stuff. So don't expect like the most amazing accurate model depending on your use case. So I'm going to do cloud. And I'm going to train a new model. I'm going to call this model cat dog model. And then I have some advanced options. You can skip this. But what it's doing is, of all the images that I've given it, it's going to take 80% of that and move it to training. And then it's going to use 10% of that, and it's going to use it to validate the data. And that is because, again, a computer is stupid. If I give it my entire training data set, right, and then I give it an image from that training data set, the computer is going to go, I've seen this image before. I know that this is a cat already, right? So typically, if you were doing this in Python or doing it yourself, you would have to create a new folder. You would have to make sure that you don't contaminate your data sets, all that stuff. But Google's going to do it for you, right? You just got to say, you know what, maybe do an 85-5% split. And Google will just modify it all for you. I'm going to keep it at 80-10, doesn't matter, right? And 10% is validation, whatever. And then I'm going to hit show less, whatever, right? I haven't modified any advanced options. And then incremental training is if you're constantly adding new data. So if you built this cat and dog, and then suddenly there's new versions of cats popping up that no one's ever seen. You want your training data to constantly get better, right? You're finding new pictures. People are crowdsourcing for you. You can enable incremental training, and it just constantly picks up this new data, runs it, tests it out to make sure that things aren't going wrong, your model accuracy is still good, keeps it going. So I'm going to ignore that. Explainability is cool too. It's a bit of an advanced feature, and I think only Google has this feature, so easily accessible, which is, why did the AI think this was a dog? And why did the AI think this was a cat? So for the longest time, my brother could unlock my Pixel phone, right? And it was kind of weird, especially when you're like in university and your high school brother can unlock your phone. It's not good. But he was able to do it, and I would have loved to know, why did the Pixel's phone's face recognition, despite me and my brothers being brothers, were kind of similar, what threw it over the threshold to go, this is actually Faisal and not my brother, right? So you can actually do that with this, where you can generate explainable bitmaps, and really what it's going to do, it is going to say stuff like this. This is a dog because of these features. So imagine it classified as a cat. What an insult to a cat, where it says, you actually look like a dog because of how your ears are, how your nose is, right? So you can actually try to understand. And what's neat about this is, the image example is kind of funny, but think about like you're doing fraud detection, right? Or you're doing credit card approvals or mortgage approvals, right? Some of these companies have these advanced machine learning models, and you might get rejected and you have no idea why you're getting rejected. So by having explainability, you're kind of open sourcing this box to see, why did this person get rejected? And this is because, we somehow detected A, B, and C were below threshold. So you can actually get an understanding of what's happening. I'm going to ignore that as well. And then I hit continue. And here's where I can say, you know what, run this for 100 hours. And that's going to like drain my bank account. However, I can say enable early stopping. And so if it cannot train it anymore, it'll just stop. To be safe, I always set it to 10, especially when I'm starting off, because I just want to understand what's happening. And if I know my training data set's not that big, it's not going to take 10 hours to train 200 images. I'll tell you how long it took. So I hit start training. Now it's training. I can go ahead to your question, run another training task, right? I can do like 50, 60 training tasks all at once. In a previous thing that I had done, I had trained this model, and it took 2 hours to train this image model, okay? And I can go into that model here, and I can see how well it did. So assume 2 hours go by, and we come back and we go, okay, this model had a cat and a dog. Let's look at how it did. So this model is actually really good. It detected cats 100% of the time and dogs 100% of the time. So based on my training data set, this might be a great model. Will it work in the real world? Probably not, because the amount of images I gave, is tiny, and they were probably all of a certain pose. Maybe if I go and take a picture of a dog that's like sleeping, it might think it's a cat, right? In fact, if I upload a picture, look at this. This is where it starts to break down. So this is what's funny, right? And this is garbage in, garbage out. I'm going to go find Keanu Reeves, right? And we're going to take this picture of Keanu Reeves right here. And we're going to save this picture to our desktop. And we're going to ask this cat and dog model, garbage in, garbage out, what is Keanu Reeves? Technically, Keanu Reeves should be a human. It should actually say, because it's not a PNG. Hold on. Okay, well, let's do that again. Open. Okay, now it's uploading it. And let's see what it says. It detected Keanu Reeves as a cat, right? Garbage in, garbage out, but if I had explainability enabled, I could actually go in and see what parts of this face did the model think that this was a cat. But now let's do a good job at it. Let's go find a dog. No, it doesn't. It's gonna. You're basically telling it, and look, it actually is pretty confident that Keanu Reeves is a cat here. Oh, whoops. And what's this label? Yeah, it's 83% confident that this Keanu Reeves looks like a cat, and 16% confidence. If I uploaded a car, we'll try it. We'll see how confident it is. So this is key things. When you look at all this cool stuff happening in the world with machine learning, at the end of the day, it's still stupid, right? You look at OpenGPT-3 and all that stuff. They're extremely intelligent systems, but they're not sentient systems. They're not sitting there going, you know what, this is actually like a dog, right? Like, this is not a cat. It's just in the inputs or outputs, but these systems have become so complex that they're giving this illusion of sentience and like wow, this is so smart. But like, it's because it's being trained on like 13 billion things, right? So that's a whole philosophical thing. Are we sentient or not? I don't know. So let's go upload this picture of this dog. And let's see what it thinks it is, right? So this 100%, look at that. It was 100% confident it's a dog. This picture might have been in the data set, who knows, right? Just by luck, but it's very confident that this is a dog and not a cat. To your car thing, before we move on to another example, if I go car, let's just use this stupid looking car. It has eyes, I don't know what it's gonna think. All right, so, like not even a child will mistake this for an animal, right? That's the thing. But what does it think? It thinks it's 99% confident that this is a dog. That's how confident AI systems are here, right? Now, maybe I could have given it a million pictures of dogs and cats, and it would have been like 60% confident it's a dog or a cat. But the point is garbage in, garbage out. That's all to remember. And the thing is, this is a silly example, but it can get dangerous. If you're building a very complex system and you have a million images, you might accidentally mislabel something. You might accidentally, if you have text data, you might accidentally mislabel that text data. And you've given it a bunch of garbage now, and it's returning results, and you might think this is a good result. So I met a friend who was telling me that they built a detection tool for dementia. And the idea was, there's a test in dementia where you have to draw a clock, and you draw 3 clocks or something like that. And depending on how the person drew a clock, you can see how far this person's dementia has progressed. So they said, you know what, let's build it on an iPad, and let's get all this training data in, all that stuff. And now the person has to draw it on an iPad. And in their testing, the model is like 90% accurate. They're like, this is a breakthrough for us, right? So they go to the clinicians, they give them the iPad. They're like, we have this advanced AI model. We've trained it on all this 50 years of dementia research. Do it. The nurses come back, the researchers come back, and they're like, garbage, right? Like, this is terrible. And so they start thinking, why? Our model is correct. It turns out at the end of the day that the test has a different medium. When people draw a clock, they're using a pencil or drawing it. On an iPad, they're not using a pencil, they're using their finger. And so that was throwing off the model completely because the model was never trained on people using their finger to draw a clock now versus a pencil. So it's garbage in, garbage out. It's like, they never thought about this context or medium. It just completely, made this model useless. So, yes?
Suppose I wanted to train animals versus humans, right?
Yeah.
Could I somehow reuse the previously trained models for cats and dogs? And
Yeah, because there is a way in Vertex, when we were setting it up, that you can start to use a previous model and then add a new label, add new images, and start to do that. So you could do that, definitely. Yeah, yes?
Is the model eventually deciding between a cat and dog just because it has only 2 labels?
Exactly. Yeah, that's it. If technically I went in and I started adding further labels to cats, and I said, these are brown cats, these are black cats or whatever, then it would now choose between 4 images. And even if I uploaded Keanu Reeves again, it might use Keanu Reeves as a black cat because he's wearing like a black suit or something. So maybe it might. Exactly, right? So that's text data. And
sorry to bother you, but can you build us a safety label? I mean, just for security,
yes,
in case you don't have this tool, you just default. I mean, is it?
you could. I think you could. But it still need to train on something because you could, the safety label would then need to have like garbage data there to say these are all nothing, right? But then your model is now training like something that you don't really want it to train. I think it might get kind of complicated. Here, you just have to it depends on the context, right? And this is why I remember reading on BBC actually just yesterday, because everyone's, hates Twitter right now and they're just saying shit about them. So BBC wrote an article and BBC said this researcher was banned from Twitter for 3 months. And the reason why was the researcher uploaded a picture of a comet, right? And Twitter's AI thought it was pornography and it banned the researcher. And no amount of appeals could fix that, right? So in their pornography model, they definitely aren't uploading stuff that's like, this is like a comet or whatever. For whatever reason, it thought a picture of a comet was something inappropriate. So it's about context, and you have to have all these safety around it. If you want to learn more about AI safety, there's a good computer file episode talking about AI safety, and there's those research groups and stuff that are thinking about all this because these are good tools. They're machines almost, right? If you think about it, it's like a car. Right? You can do a lot of things with a car, but you can do a lot of bad things with a car too. So it's really about how you control these things. So that was image data. We were like 30 minutes in. So I'm going to talk about text data. Right? Image data is fun, and you might have an image problem. Well, what about you have a text problem? Text problem as in a numerical problem. So let's build a credit card fraud detection system. Right? So I'm going to click create, and I'm going to type in credit card fraud. Now, you can build this internally for your system. Maybe you have like a small Shopify competitor, right? And you want to build something that can, when people are buying credit cards, you want to know, is this person legit, right? Based on things we've seen in the past. So I'm going to go here, I'm going to click tabular, right? Because this is not text data. This is tabular data. And tabular data is numbers, and we're working with something. So I'm going to say regression and classification. Classification because this is either fraud or not fraud. Simple. I'm going to hit create. Now, I need a lot of fraud data. One of the fantastic things about Google Cloud is there's a ton of sample data sets you can get from their database called BigQuery. And if you've never used BigQuery, BigQuery is basically a SQL with steroids. Like imagine like your Postgres database, but like it's so jacked up. It's like, you know, like the most powerful database on earth, right? Where you can do like terabytes of calculations within seconds. One of their big customers is Moderna, where they're just uploading a bunch of data there. They're able to run SQL on it. It's SQL still, and extract insights from it. So there is a SQL database on BigQuery that is a good learning database for machine learning for credit card fraud detection. So I'm going to say select a table or view from BigQuery, and I'm just going to type in the BigQuery dataset name here. And I found this because I went to BigQuery. If you want to go check BigQuery out, you can go to Google Console here, type in BigQuery, and click on BigQuery. And at the left-hand column, you'll see something called public datasets. BigQuery public data. If you don't find this on the left column, you could also just Google it, and there's like a whole page for it. But look at all this different data here. There's Austin crime. So if you want to learn, I mean, if you're thinking of data sets, you're like, I don't know, I don't have anything idea. You can just go to BigQuery. You can learn about crime rate in Austin, and you can learn about the address. So this data set has what? How many rows? There is 116,000 rows of data that's telling you address, the census, description of the, I guess, the crime, the X and Y coordinate, the year, the zip code of the crime. So you can come up with maybe a classification where are you likely to, I don't know, get stabbed if you're in a certain zip code or something, right? Based on this crime data. There's Bitcoin blockchain. There's databases on solar data, space data, black hole data. Lots of cool stuff. So I found one, there's COVID-19 data. So if you want to do something cool there. So lots and lots of data. I found one that is specific to credit card fraud. So I'm just going to copy and paste the path of that table. I'm going to hit continue. And it's going to say, okay, I found 31 columns. I found 30 which are floats, which are numbers. And I found one column which is an integer. And that, because I've looked at the data set before, an integer, it's either a 0 or a 1 in this case, which is either fraud or not fraud. Simple, right? And the rest of the floats are these things right here. So in machine learning, these columns, you can refer to them as features, a feature of a model, right? So think of it like a red sports car. What are the features of a red sports car? I guess it has like a good muffler, or like it can go super fast, stuff like that. So the same way, a model has a bunch of features. Because this is credit card fraud data, it's sensitive, whatever, someone has gone ahead and created a bunch of these features already for me. V24, V25, you can actually read about the description and see what all those are. But for the sake of our thing, assume all this are different features. So assume V26 is like, is this a 4-year-old kid, right? Like the age of the credit card holder, right? If it's a 4-year-old kid using a credit card, chances are it's going to be a chargeback, right? So imagine something like that. Or maybe V24 was like, is this person, has this IP in the past been associated with credit card fraud, right? Yes or no. So there's a bunch of features here. So what I can do is I can say, all right, all this looks good to me. So, whoops, I'm going to train a new model, just like what we've done before, right? And it's going to be AutoML, because I'm not going to write. And I'm going to write, this is to determine fraud. And it's saying, what am I predicting? The target column, right? Am I predicting some random feature? Am I predicting if this is like a 4-year-old kid or not? No, this is a classification. So this is a 0 or 1. So this is going to be class. And a class in this, when I looked at the description, a class said 0 means fraud, 1 means not fraud, right? And I'm going to say, all right, sounds good. Again, I can do the same stuff here, right? Training, validation, test. How do I want to do all this? So I'm going to hit continue, and I'm going to review everything. Yes, amount is a float, so I don't want to predict on amount, right? I want to predict on a class. So everything else looks fine. Now, what if I realize that, it doesn't matter on my store how much the item is, a fraud is a fraud. Like people are scamming me even for like $1, people are scamming me for $100, right? So I can actually say, hey model, don't train on amount, because that I know from my insights, that has no implication of whether this transaction will be a fraud or not, right? So imagine a legitimate use case is probably IP address. Based on this IP address, it doesn't matter. The fraud happened globally for me. Like someone like Shopify probably sees fraud all the time. It doesn't matter where it's from. And so for them, they're like, you know what, maybe they're like, it doesn't matter where fraud's happening from. We don't care about IP address. What we care about is probably like if that person has like a browser extension or something, and maybe they're capturing that. Browser extension called like credit card generator or something. So I'm going to keep everything. I can also say the following. This gets complicated, but I'm going to quickly summarize this. In my data set, 95% of the transactions are legit. Only 5% are fraud, right? So there's clearly a weight, like in my data, there's a bias towards everything looking good. So I can go and I can change the optimization objectives here, and I can say, you know what? Maximize precision for the less common class, right? So the less common class here is fraud. So I want to make sure my model is hypersensitive to fraud. So it's going to internally optimize for, really take a look at what is really differentiating between something that is a fraud or not fraud, right? And so I can go in and I can mess around with this. And someone asked a question earlier, how many times can I run this? I don't know if this is the right thing to do. So I can actually hit this. I can choose some value. I can mess around with this, and I can just hit continue, train it. And then as it's training, I can launch another training job. So by the time it's done, I have like 5 models with different objectives ready to go, and I can actually train it on my like real world data and see what's happening, right? Which one of these 5 models is performing best for me. So for now, I'm going to keep everything default. I'm going to hit 10 hours. Doesn't matter, it's going to stop. I think it took 2 hours to stop. And once it's all done, if I go into my CC endpoint, so it's going to take 2 hours. If I actually go into my training here, you can see that I'm training my cat dog model still and my credit card fraud model. 17 minutes have gone by since we launched the cat dog, and only 10 seconds has gone by. So when I ran this before, it took 2 hours usually to run them, so that's cool. I can go into endpoints. I can click on credit card, and I can click on that model. And I can see how well did this model do. All right, so 100% of the time, it knew that it caught something that was not fraud. So 100% of the times, people who are legitimate are never going to have trouble. But 20% of the time, the fraudsters are going to get away. Because 20% of the time, something that was a fraud did not get classified as a fraud. It got classified as a 0, which is it's a good transaction, right? So maybe this is fine for me, right? Maybe for me, 20%, it's all good. It's not like I have a crazy amount of sales. Shopify, imagine 20% of their sales, people got away with fraud, they'd go bankrupt. So they're like, okay, this is crazy. Our credit card processor will shut us down. Let's go back and retrain on this data. Let's go back and play with those objectives. So it's funny because a lot of this comes down to how you mess around with this data, right? I can play with this confidence threshold. So this is 50% of the time. If I change this confidence threshold to like, how confident are you? If I say the model has to be, whoops, something's going on with this. Yeah, this model is actually really garbage because it's like anything above 50% confident, it's not confident about anything. It just doesn't know. So I have to go back and train it. 60%, if I say 60%, tell me. So 60% of the times, it got a confidence threshold with 60, it let through 15% of fraud transactions. So I can play around with this data. I can go and retrain it again. But say if I'm happy with this, right? It's the same as what we did before. We have an endpoint ready to go. I have my test data. I'm not going to type all this stuff in because there's a lot of features here, but I have my API ready to go. All I need to do now is hook it up to maybe my Stripe account or maybe my database, and as long as I pass in the right inputs, it's going to give me the output. And really, that's it. Like, if you noticed, I've written barely any code this whole time, right? Actually, I did not write any code. I just copied and pasted from Sublime. So you can do a lot of powerful stuff in Vertex.ai as long as you have the data sets. So, which leads to the final point of this talk. Where do you get data sets, right? BigQuery is a good spot to find a bunch of data sets. Another good spot is this thing called Kaggle. And Kaggle has a whole bunch of data sets. You can actually do competitions if you want to compete. But if you want to find a data set here, for example, the cats and dog data set, this is where I found it. I searched cats and dogs. And I found a cat dog data set that was someone did 5 years ago. It's 228 megs. It has a bunch of images. I can download that. I can train it on Vertex.ai. I can play around with it, right? I have other data sets I can find, audio of cats and dogs. If I want to build an audio classifier, I can do that. So lots of cool stuff. I can do all this. And really, it really comes down to just trying it out on Vertex. Because Google's made it so easy now to just play around with this data, you can easily get an intuition for machine learning by throwing all these data sets in, running training jobs. It doesn't really cost much. I think 2 hours of training will probably cost like $5 or something, nothing too crazy. Plus, because you're new Vertex.ai, I think you get like up to 100 hours for free. So it's some plan. So a lot of times you're not paying for anything. And then this is a good way to level up your mobile apps, level up your web apps, because it's so simple to do as long as you have all the right data. The last thing I wanted to show before I open it up to more questions is Hugging Face. So Hugging Face is once you become kind of advanced with Vertex and you kind of understand the intuition and you've done some readings and stuff, and you're like, you know what, Vertex is not, it's still good for me, but I actually want to write some custom code now, right? Hugging Face is the next step in your journey. And Hugging Face has a bunch of models, like thousands and thousands of models that you can use pre-built and just take that. You don't have to train any model. You can just take Hugging Face models and put it in your application. So for example, if you want to build a chatbot, actually forget chatbots, they're overrated. Let's do speech recognition, sure, right? So I click speech recognition, and there's a bunch of models. Facebook has built some, all these guys have built models. So let's just click on this one. And now it can say, all right, here's speech recognition. So it's a model that I'm going to build. I'm going to go record from browser, testing, 1, 2, 3, how does this work? And I'm going to play myself back. I'm assuming it's working. Testing, 1, 2, 3, how does this work? And now I'm going to say compute. Testing, wow, it got that really wrong. Testing, 1, 2, 3, hot as this work, right? This is a really small model, but the thing is, if I want to use this now, I can go and I can click use in transformers. It's giving me the sample code that I just have to put into my Python. And as long as I send it now the inputs, it's going to give me the outputs. It might be a bullshit output like that, but that's Hugging Face. So this is a model. This is just a small model. I can find a super large model. I can go and I can find a bunch of different stuff here. So summarization, let's see how summarization works. So this is some random input. If you want to build, I saw that Google Workspace came out with a feature today. If anyone uses Google Chat, I don't know who does, but if you do end up using Google Chat at work, there's a new feature now called summarization, where if you've come back after a vacation, there's a lot of text, Google will say, here's what you missed and summarize the whole conversation for you. You might think wow, that's really cool. How do I build that myself? You might start thinking about writing a bunch of code, but use a Hugging Face model. Facebook made this model, so imagine it's this text here. I can hit compute, and it summarized it down to just 4 lines, right? I think it did a good job. If I look at this entire paragraph here, I think it did an okay job. And so you can just go in, If I want to use this for my code, using transformers, copy this, paste it in my code. As long as I know Python, I can start building this, using this model in my code and make it more intelligent. So both of these, Hugging Face has nothing to do with Google. I just like throwing it in because it opens it up. It opens up your application to a lot more powerful use cases. But with that, I want to say thank you, which is my second slide. Thank you, and if you have any questions, I'm happy to ask, because I know we have probably like 5 more minutes here. Yes?
Yeah, currently use Vertex.ai for unsupervised learning.
I think no. For unsupervised, so there's a gradient on Google where on one hand you have Vertex.ai, which is you're doing very little code, right? But there's some parameters you're playing by. You can choose like the 6 data types. On the other hand, it's like Wild West, like you're writing TensorFlow or Keras or scikit-learn and you're doing everything yourself. In the middle, where you can do unsupervised learning, you can do unsupervised learning here, you can do it in the middle too, called BigQuery ML. So if you have a lot of data in your SQL database, I was going to show it, but I didn't, but take a look at this SQL. If you've done SQL before, here was my example, but we never got to it. But if you've ever done SQL before, this is just a SQL thing. I'll select all my data from a fraud detection database. So let me just get rid of all this. Okay. So, and then I'm adding a bunch of stuff on top here where I'm saying, take all this data that's from SQL, but create a model out of it. And in here, you do have the ability to run unsupervised, where it can do k-means clustering. It can just like, and we've done this for a customer way back when they had a bunch of like phone data. We had to like just figure out what's similar in this phone data. We did k-means clustering where we said, create 4 buckets and just kind of figure out what's similar between all of them, right? And it went ahead and did all that for us. So you can do that with SQL data. You don't even have to write any code. So, I mean, the code is SQL. So this is where like the middle part is, where BigQuery ML. So it's Vertex.ai, BigQuery ML, and then like the custom Python stuff that you're doing. Any other questions? Yes?
Does it offer RPC on top of REST? And second question, what is the relative cost of operations for the endpoint?
I think the endpoints can get pretty expensive, which is relative, like $100 or something, depending on the CPU you're deploying it on. So if you have a really large model, like you had like 50 million images of cats and dogs, you can't run that model probably on like, it's probably like a 6 gigabyte model. You can't run it on like a small virtual machine. So you just size it appropriately, and that's what you're really paying for. You're paying for the size of that machine. When I go to a model here, if I go into model registry, and I can click on a model here, if I do, let me see if I can deploy it here. Yeah, deploy to endpoint. So this is what happens here. If I click deploy to endpoint, I can choose the endpoint name. I can say whatever, continue. And here I can say number of nodes. And I think I missed it. There was a way to advanced options. What model is this? 1 second. This is credit card. Oh, this is cat dog. Never mind. For credit card data, I can do it. For cat dog, for an image model, it's going to just appropriately size it for you, and you have to figure out how big that machine is. For something like credit card data, when I want to deploy it, I can choose the machine type. I'm not sure why they don't let you choose it for the other, but I can say continue right here. What type of machine do I want, right? Do I want an N1 standard 8, or do I want a high CPU machine? Depending on my model, I can choose a type of machine. And I'm actually not sure if under the hood it's using RPC. I think it is probably. Yeah. For the REST API, I think it is. It's only REST. Oh, so I mean, maybe there's a way to do RPC. I'm not sure. Yeah. Cool. Any other questions? Yes. You have a question? No? Someone had their hand up. All right. If there's no other questions, feel free to add me on Twitter for the few amount of weeks that it's around. Or you can add me on LinkedIn under faisalabid. Or if you want to email me about something specific, go ahead. So those are 3 of my contact details. And thank you, everyone.